Hello, welcome to Z Talk. We're going to start a new series of sessions to talk about Helm. As we know, whenever an application needs to be deployed to a Kubernetes cluster, it involves a number of components. So how do we organize those components in the right order with the right dependencies, and how do we deploy the right version into the cluster become a challenging topic that we have to deal with daily, right? So Helm comes into the picture under these circumstances to facilitate deploy the entire application package into the Kubernetes cluster. So the goal of this series is to help you better understand Helm and be able to create your own Helm chart from scratch. All right, stay tuned. Okay, Helm helps visualize the application as a package where all the dependencies will be wrapped up together, and the entire package can be shared as well as deployed to the Kubernetes cluster. What's more, it also facilitates to upgrade, roll back the changes by maintaining the versions. We can vision Helm like apt or yum package manager available in Linux operating systems. The main concept of Helm is about temporizing the deployment configuration so that the values that are going to be changed for different environments can be fed as an input value or a separate file or a separate value file. And the templates can be stored in a repository like GitHub, and the only the values that are gonna change depending on the environment need to be maintained. That's the goal, right? And it can also be integrated easily with CI/CD pipeline. All right. So here I list out the main component in Helm. So firstly, we need to install a client. Basically, it's a CLI, which facilitates communications with Kubernetes clusters, right? And charts are application definitions. It's composed of a collection of YAML configuration files in a defined structure. And repository, like GitHub, repository stores and manages the charts. And release, so the chart instance, once it's loaded to Kubernetes cluster, it will be a release, and each release will have a version. All right. Okay, charts. It's a bundle of YAML files, and here is the example of a on your left side. Here is the example of the directory structure of a Helm chart. The chart, the YAML file contains the information about the chart. Values, the YAML is the default configuration values for this chart. Charts directory contains any charts upon which this chart depends. And templates directory, it's a directory of templates, which is going to be combined with values. All right? It will generate valid Kubernetes manifest files out of templates. And on your right side, is an example of value injection into template file. As you can see here, the values that YAML is the default value that we're going to use out of box to be ingested to templates. So you can see that image name is my app, port is 8080, versions 1.0.0, right? But we can overwrite these default value by creating our own values that YAML, like this, my hyphen values that YAML. And inside this file, we just need to define the property that we need to override. For example, version, instead of using version 1, we're going to use version 2. So we define the key value pair, version key value pair, and put the value 2 out there, 2.0.0. And when we issue the Helm install command and include the YAML file, basically is gonna override the default value and use version 2.0.0 of the application image. All right, that's pretty much it. So let's jump to a demo. So I will walk you through more detail about charts. Cool. By the way, before I'm doing that, remember thumb up my video and subscribe my channel. And feel free to leave comments. All right, thank you. Okay, there are some preparations we have to take care before we can start our demo. Firstly, we need to install Helm CLI on our laptop. I'm using macOS, so the easiest way is install Helm via Homebrew. So you just need to issue brew install Helm. Homebrew will take care of the rest. If you're using different operating system like Windows, you can try Chocolatey. Just click installation. By the way, I'm on the Helm official website, and click installation and pick your flavor of operating system and follow the instruction. All right, cool. Once Helm is installed, you can verify by going to your terminal and issue Helm. If everything was installed correctly, so you should be able to see some return like this. Just pay attention on this section, environment variables and default directory. Here it lists out the default directory where your Helm related configurations will be stored per operating system here, right? And also the environment variables, for example, Helm _data _home, that's set an alternative location for storing Helm data. Basically, that's once you download for example, a Helm chart from the repository, that's where that chart will be stored on your local. All right, you can modify. For me, I'm just gonna use the default here. For your use case, if you need to change, you can change the environment variables accordingly by this reference. All right, cool. So once Helm is installed, the next step we can browse get the charts, right? So visit this artifact hub to explore Helm charts. Go here, and you just need to search for the chart you're looking for. For example, Prometheus. Hit enter, and it's going to list out all the charts related to Prometheus. Like the first one is the official chart for Prometheus, and there are other charts provided by other engineers. All right. So click here, and it shows you the instructions how you're gonna add that chart to your local and how to install that chart. Right. So this is one way of browsing charts. The other way, you can search charts on your from your Helm CLI. So let me jump to my terminal and just issue Helm search hub. Hit enter, and you can see here it lists out all the repository or charts available inside that's hub. The hub is quite similar like Docker Hub is a location where repositories were stored, right? So here it lists out all the chart available inside of that hub, and if you know a specific chart you're looking for, you just need to search for hub and the name of your chart, for example MySQL, and it lists out all the chart related to MySQL, or another example like the one I showed just now, Prometheus. All right, it lists out all the Prometheus charts available. Cool. All right, now we got Helm CLI installed on our laptop, and we knew the basic Helm command to search for charts that we're looking for or search charts on the Hub website, right? Next step, I'd like to show you how do we install a chart on a Kubernetes cluster and how do we customize on top of that existing chart folder, like overriding the default configurations like I mentioned on my slide just now. All right. Okay, for doing that, there is another preparation that we have to take care of first. We needed to set up a Kubernetes cluster environment first. For that, you have multiple options. Like you can set up a Kubernetes cluster on any public cloud vendor like AKS on Azure or EKS on AWS, but that will be a cost for that, right? For testing purpose, we can actually use Minikube to set up a simple Kubernetes cluster on our laptop without any cost. I used Minikube actually in my previous video for Prometheus and Thanos, but don't worry if you didn't get a chance to take a look. The installation is pretty easy, and here you go. Just log on to the official website of Minikube, and here you go. It shows the installation step by step. So basically, we needed to install two components. One is Minikube CLI, like Helm, right? Follow the instruction based on the flavor of your operating system. Again, for macOS, you're going to use brew to install Minikube. So once Minikube is installed, you can jump to your terminal and just issue Minikube version, and here we go. So if everything works as expected, you should get some return, like show you the version of Minikube, right? So after you install Minikube CLI, there's another dependency. So basically you need to install a virtual machine manager to host the Kubernetes cluster, right? So for that, you got different options like Hyperkit, Hyper-V, Padman, VirtualBox, VMware. You can choose whichever in this list. For me, I used VirtualBox. So again, for installing VirtualBox, you can use Homebrew or just log on to the official VirtualBox website. It has all the instruction detail. All right. So once you got these two components installed, you can start Minikube. For me, I use VirtualBox to host the Kubernetes cluster, right? All you need to do, you just need to issue this command to bring a Kubernetes cluster up and running. So let me jump to my terminal and just issue Minikube start and -, just follow just define the driver. The driver will be VirtualBox right here. So just driver equal VirtualBox. Hit enter. All right, so Minikube will spin up a Kubernetes cluster. Just give it a little bit time. All right, the Minikube is started successfully, and the Kubernetes cluster is also ready to use, right? Now, if we issue kubectl get nodes, and you can see it's a really simplified version of Kubernetes cluster where only one node is up and running and being hosted on the virtual machine, right? And the node acts as both control plane, master, and slave. All right. We got our cluster ready. The next step, we can install whatever charts that we want to test out. And for this demo, I'm going to use Grafana Chart to show you how do we deploy the chart onto our cluster, and then how do we customize on top of it. All right, so let's jump to the hub page again and search for Grafana. And here is the Grafana Helm chart. Firstly, let's go to the right side of the page, and if you click install, you can download. It shows basically how do we add the repository and install the chart to our Kubernetes cluster. We just need to follow this command right here. And also, if you want to download this chart to your local, here it provides a link. Just click that link. It will download the package to your local for your review. All right. And the next button is show templates. Basically, it lists out all the configuration templates inside of these Helm charts. And as of now, don't worry about the syntax like this just yet. I will explain more in detail when we start building our own Helm chart from scratch. All right. Let me cancel it out, and let's scroll down to the middle section of the page. And here is the most important part. It's list out all the configuration parameters available for these Helm chart. Basically, you can see, for example, replica, right? And each of parameters, there is the default value assigned. So basically, those are the values will be passed to the templates. And we're gonna highly depend on these documentation when we customize based on our own use case shortly. All right, so we will review it back a little bit later. So let's install the chart with the default configuration first. So follow the instruction. The first step, we need to add this Grafana repository to our laptop. Copy this command and paste it here. Hit enter. And see, I already add this repository to my local. And if you issue Helm repo list, and here you can see Grafana repository was already added, right? And the next step, we're gonna install, and the install command is like this. And before that, we can issue a Helm repo update to make sure we got the latest update from the repository. And then we can issue a Helm install, and here is gonna be the name of the instance. I will call it demo, and then followed by the repository name, which is Grafana, and the chart name which is also Grafana. And I just gonna install this chart to my default namespace. So hit enter. All right. If we issue kubectl get PO, and you can see the Grafana pod, it's being created, right? Let's give it a little bit of time. All right, the status is showing running. Cool, we got the Grafana pod up and running, and let's get in to verify if it's working as expected. All right, let's first issue kubectl get service to check the type of a Grafana service. And as you can see, with the default configuration, the type of Grafana service is cluster IP. So as you know, cluster IP is only for communication inside of the Kubernetes cluster. To be able to get access to Prometheus interface from my laptop, we have to do little modification right here. There are different options. For example, I can simply do a port forward. Basically, it's map a port on my laptop so that I can use localhost with the mapped ports to get access. Something like this. kubectl get PO to show the pod name. kubectl get PO. And then we can do kubectl port forward. Copy the name of the pod and let's map it to port 3000 on my local laptop. Hit enter. So now we can jump to my browser and just hit localhost 3000. All right, hit enter. Now we get the login page of Grafana. All right, and go back to my terminal. Things is this way it only works for this session. So if I turn off this session, like I cancel it out, I will not be able to get access to this interface anymore. That comes to an alternative option. What we can do, we can change the type of Grafana service from cluster IP to node port. That way we can also get access to the port, the Grafana interface. Let's try that. Just issue kubectl edit SVC and the name of the SVC here. And all we need to do, we need to go to the bottom and change the type from cluster IP to node port. Basically, the node port is able to expose the service out of the Kubernetes cluster, right? So save it, and let's issue kubectl get SVC again, and you can see the type was changed to node port. And now we can just issue minikube service list. Basically, this command lists out all these services that are being exposed out. Hit enter, and we can see, here we go. You remember, our Kubernetes cluster is being hosted on the virtual host. Basically, it's the VM. So this IP address is actually assigned to that VM, right? So what we can do, we can just copy the URL here and paste it to our browser. Hit enter. Boom. You can see we can also get access to the login page this way, right? So next, we need to get the password to get access Grafana, right? All right. So basically, the based on the configuration of the chart, the password is stored as a secret inside of the Kubernetes cluster. We can do a kubectl get secret to take a look. Let's go inside of these secret by kubectl edit secret. Hit enter. Remember, so inside of the secret, everything has to be encoded at base 64. So here, admin password, to be able to get the plain text of the password, we need to do some decode. So let's copy this string and exit out. And we can do an echo and pipe it to base 64-d as decode. Here we go. This is the default password of admin user, right? Let's copy this and paste it in my browser. The username is admin and password here, and hit login. All right, now we log in to Grafana successfully. Cool. All right, so far we have been just using the default configuration. You may ask, what's the default configuration, right? So like I explained in the hub, here it lists out all the configuration parameters, and these are default values that were assigned to each of the parameter. So by the way, I downloaded the chart to my local, so we can take a look from my Visual Studio Code. So go to my Visual Studio Code, and you can see the structure of these Helm chart is pretty simple, and there is the templates directory. Basically, it lists out all the template configurations inside of these directory. Basically, that's exactly the same thing we reviewed previously in the hub here, and click templates, and it lists out all the configurations templates. And just give you an example like where the default password was configured. Here are in the secret.yaml, and you can see here is the admin user and admin password. And what is the password look like? It's gonna grab the admin password inside of the values.yaml file, and then once they grab the password, you're gonna encode it as base64, right? That's basically these templates for. And then we can jump to values.yaml. So let me go to Visual Studio Code, and you can see the values.yaml file. Basically, this is where we define our parameter and assign the values to the parameter. And when we deploy, create an instance to our Kubernetes cluster, whatever defined inside of this values.yaml file will be passed to the templates, and the build will based on the configuration right here, right? So let's go down, and as per the templates in the secret.yaml is looking for the secret.yaml for the password is looking for these key inside of the values.yaml. Let's jump back to values.yaml and search for admin password. Here we go. Admin user and admin password. Basically, it just grab the key value, the value of the key, admin password key, and then encode it as base64. So let's do some customization on top of these existing the default configuration. So what we're gonna do, we need to create a new file. I will call it my values.yaml. All right, and to start with something simple, let's just let's see what we can test it out first. We can test out. All right, how about let's downgrade or Prometheus. Let's see the default version of Grafana. Here, the default Grafana in this chart is 7.5.5, which is the latest version, right? For testing out or customization, if it's able to override the default configuration, let's downgrade the version of Grafana to 7.3.0, and let's test it out. Like I mentioned, how we're going to do that in my previous slide. What we need to do, we just need to create a new file right here. I call it my values.yaml, and copy the parameter down there and override with our customization. Like we're gonna use 7.3.0, right? And save it, and let's try something else. Let's jump to the documentation. All right, replica. Basically, replica defines the number of Grafana instance, we're gonna build inside of cluster. So the default value of replica is 1, right? Let's change replica from 1 to 2. And what we're gonna expect is there are gonna be 2 Grafana instances up and running in our cluster. All right, let's just test out these 2 changes first. We need to apply these changes to our cluster by jumping to the terminal and issue Helm upgrade install my values.yaml. Oh, actually, let's try something else. Remember that the default password was too complicated, right? It's hard to remember. Let's override the default password. Take a look the secret again. Secret, the default password was looking for these key value pairs, admin password. Let's copy that and my value here. Let's add another parameter here. We'll give my password. All right, let's save it. This is gonna be your password. Let's see if it works. So jump to my terminal and apply this change by helm upgrade -- install demo Grafana /Grafana and apply that my customization file, my values.yaml. Here, hit enter. All right, the apply was successful, and take a look by kubectl get PO. We should see 2 Grafana instances up and running. Let's give it a little bit of time. All right, see here the 2 Grafana instance is showing running, and here the old pod was terminating, and there are 2 Grafana instances is up and running right now. Hit enter. All right, so the replica these property works is override the default configuration, right? And let's check out the version of Grafana. I'll just issue kubectl port forward, and let's pick the name of the pod. I'll forward to 3000 and jump to my terminal and my browser, hit local host 3000. All right, here let's try admin and password, because it's gonna be my password. All right, see, so this time everything was changed, override. The new password is what I defined in my custom values.yaml file, my password. And let's also verify the version, and you can see the version of Grafana was downgraded to v7.3.0, which was exactly what we defined in our customization values.yaml file. All right, that's basically how we customize on top of the existing configuration or on the existing Helm chart. All right, let's continue customizing these Grafana Helm chart further to get you more familiarized with this operation. This time, let's do something more challenging. How about we customize to enable ingress? Basically, we're gonna enable HTTP TLS, HTTPS, so to secure our Grafana access. So for doing that, there's some preparation on Minikube side. We need to enable the ingress add-on. Basically, it's a simple command. Let me jump to my my terminal, and let me cancel that out here. And all we need to do, we just need to issue Minikube add-ons enable ingress. So basically, once we enable ingress, the Nginx ingress controller will be installed automatically to our Kubernetes cluster. Let's give it a little bit of time so I can show you. All right. So if you issue kubectl get namespace, and you can see there was a new namespace ingress nginx created, and if you do a kubectl get po inside of these namespace, and you can see the nginx ingress controller are up and running here. Cool. Let's jump back to the values.yaml file and find out the section where ingress was defined, and take a look at the syntax or the argument, the parameters first. And we're gonna use this section as reference to customize in our my values.yaml. Here we go. So I did some cleanup, and here, as you remember, out of box, the ingress was not enable false. So I enabled by changing false to true. And annotation, as you remember, after I enabled the add-on on the Minikube side, the Nginx ingress controller was installed automatically, so that the ingress class will be Nginx, and the path will be the root path, and the host, we're gonna give a DNS name of our Grafana access, so that we can use the DNS name here instead of the IP, right? So I will call it grafana.zztalk, all right? And the TLS, so for enable TLS, we're gonna use a self-signed certificate. So and once we create a certificate, we need to store the certificate inside of the secret in the Kubernetes cluster, right? So I will the secret will be named as Grafana-TLS. All right. Finish up the configuration. Let's jump to the terminal, and let's create the self-signed certificate first for this new DNS we defined. All right. So I create a new folder called cert, and here is where I'm gonna store the self-signed certificates. So I'm gonna use SSL, openssl, to create the self-signed certificate. Here, I will give the certificate will be valid for a year, 365 days, and let's hit enter. All right, give a passphrase. Hit enter. All right, so the country will be US, state California. Okay, the domain name will be, let's copy grafana.zztalk. All right, so here we go. The certificate was created. So now we need to create a secret and store the certificate inside of the secret, right? So let's issue kubectl create secret generic. I will call this secret as name this secret as grafana-tls from the file. The key will be tls.crt and the file will be this guy, cert.pem. All right, hit enter. Here we go. The cert was created, and if you issue kubectl get secret, you can see Grafana TLS secret was here, was created right here. Cool. And now we can apply or changes to the Kubernetes cluster. So here, let's change back the version to the latest, which is 7.5.5. Right? So version just confirm. Yeah, 7.5.5. And let's change the replica back to 1. The rest keeps the same. All right, let's apply to see how it goes. Upgrade, install, demo, grafana/grafana-f. values.yaml, hit enter. Oops, there is the error message. Failed calling webhook validating. Oh, so I googled its errors, so it seems this what I got, and this is the same error. Webhook validate nginx ingress.kubernetes.io. So it seems the fix was just delete these validation webhook configuration, and I tested out, it worked. So I'll share this link in my description. You can take a look. So all we need to do, we just need to delete this webhook validating webhook configuration, and then run that again. Hit enter. All right, the customization was applied successfully, and let's do a kubectl get PO again. And you can see the number of pod down to 1. Let's also double check the secret one more time by kubectl get. Let's go inside of the secret by kubectl edit secret, the name of this Grafana TLS. And you can see the key value pair. The key is TLS, the CRT, and value is the cert that we created via openssl just now, right? So looks good. To correlate the syntax of creating secret, kubectl create. So this was the command, right? So here we name the secret as Grafana-TLS, and the key value pair, the key will be TLS the CRT, which was exactly this thing we see inside of the secret, and the value is the file, the cert file. Cool. And last but not least, we need to add the service to the ASCII host, so it's able to recognize the host name, right? So jump to cube, issue minikube service list, and we need to correlate the IP here with the host name. So let's issue sudo vi ASCII hosts. And enter. And here, the IP and the host will be grafana.zztalk, right? And save it. All right, now let's take let's try to log on from our browser to see if it works. Hit to my Safari, and this time I'll do https:// and the name of our hosts, Visual Studio Code grafana.zztalk. Hit enter. Grafana.zztalk. All right, we get access. We got the login page, and see now the Grafana is secured by HTTPS, right? So let's log in by admin, and the password will be this guy, my password. Copy, paste. All right, we logged in. The version back to v7.5.5. Perfect. All right, guys. This is pretty much what I want to share in the first video of this series. We got familiarized with the Helm chart structure, and we are able to instrument or deploy a Helm chart to our Kubernetes cluster and customize on top of the Helm chart. All right. So the next session, I'm gonna introduce or explain more in detail about the syntax, how we're gonna build the template. And then the last piece, the last session, I'm gonna use another real project or a real example to show you how do we create our own Helm chart from scratch. All right, stay tuned. See you next week. All right, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.